So good morning, everybody. I'm Costanza Giroffi, and I will chair this morning's session. And the first 15 minutes will be focused on the discussion we had yesterday. If I understood correctly, in the end, we had 4 different groups. And I think that therefore that should be 4 persons reporting about work in the different groups. I don't know if any one of those persons is already here. If you want, okay, yes. Okay, which group was yours?
Diffuse matter.
Okay, diffuse matter and galaxies, correctly. Okay, this.
Sorry, hold that thing. Use that thing.
Okay, so I wrote my notes. I have them on my phone. I'm not checking Facebook, I promise. So the diffuse matter, the group that was talking about Chandra's legacy for diffuse matter in galaxies met. There were a few of us. So Daniel was there, Shanskriti was there, Herman was there, Tawi Watt, Armando joined us remotely, and of course I was there. And I do want to thank Tawi Watt for taking very good notes about our discussion, which allowed me to actually piece it back together this morning. The key theme, I think, that emerged from that is that we really need to take advantage of Chandra's exquisite spatial resolution, because that is something that is not matched now, and really it doesn't look like it's going to be matched for the foreseeable future. You know, we really were thinking links is the next step that will improve on what Chandra can do. So in terms of spatial resolution, but also taking advantage of that spatial resolution for high resolution spectroscopy. So some possible, projects to use up our 5 megaseconds that we've all been promised. The first one is to expand the sample of deeply exposed AGN sightlines. Right now, there are these 3 calibration targets, Markarian 421 and Parkes 2155 and 3C273 that are really well exposed. There was a strong preference to get a few more targets. Probably there would be some balance between how many we can do and how deep we go, but especially to nail oxygen lines in those, to get beta and alpha lines so that we can measure velocity, dispersions, and also I think we have time for questions later. And also to get other species as well. So that was one thing. Also deep and also galactic low mass X-ray binary. So thinking of some other sources that can be used to probe other parts of our own galaxy. This, of course, the AGN sightline stuff is all for the Milky Way halo. Beyond that, deep HET observations of nearby galactic bulges where there are very large, dense populations of X-ray binaries and supernovae remnants and things like that. So there is an ongoing project to do this with M31. There's an idea to do this with M33. Some other targets include M83, M51. So you just get a slew of information, and that requires Chandra's really good spatial resolution, so you can separate all those overlapping spectra. And then deeper observations of AGN that are embedded in galaxy clusters. For example, looking at NGC 1275 and Perseus, or the quasar that's in the Phoenix cluster, for example, or even Pictoris A, to try to measure absorption within the cluster or the galaxy against that. So those were the major high resolution spectroscopy projects. A couple imaging projects were to map the central region of our own Milky Way as a sort of legacy for things like Rubin, because again, Chandra is not going to be around forever, unfortunately. And also map a complete sample of nearby galaxies. So where we have kind of a wedding cake strategy, you can go further out and get a complete sample of large galaxies, and more nearby, you can get a complete volume limited sample of smaller galaxies. The 2 software and calibration priorities. The first one is to calibrate HETG so that we can use it on HRC. It sounded like that was really important to do now. Another is to calibrate LETG below 0.2 keV. That sounded very appealing, and I think that would be an interesting thing to do if we can do that. It also sounded like there is some interest in collaborating on possible proposals among the group, so we'll see if that comes to fruition, but there was a lot of good discussion. All right, I think I've used my allotted 2 minutes and then some.
Thanks, Eric. Okay. Other groups? Is there someone Okay, please, Jesús.
So we, the star people, agree that Chandra has the advantage of the higher resolution, that it won't be rivaled by any future mission. We started by saying that we should take advantage of the high resolution camera, which we rarely use in the Chandra community, at least not in my area. For example, the high resolution camera can be used to follow up the variability of stellar clusters. And we also discussed some details on, like, for example, for the stellar people, now the soft lead, I said, like yesterday, it was hurtful that we're losing a lot of photons in the subbands. And we need to account for this. We need deeper exposures, deeper spectra in order to get better physics. So we better start like pushing the panels into the people to try to accept more longer exposure, higher resolution spectra. One thing that I would love to see is deeper spectra from Wolf-Rayet stars of another type, other than the nitrogen-rich stars. For example, we also have the carbon-rich or the oxygen-rich. There's also a hot topic of planets detected around white dwarfs, and these, if the white dwarfs are accreting material from planets, they may produce hard X-ray emissions, so this can be also detected by Chandra. We need maybe a different panel for TOO, like Novi, but cataclysmic variables. We need to be, I think we're waiting for one to explode within now. And when I wrote here, think of only allocation for gratings. Need long exposure for these. Only 4 HETG proposals were approved last time. So we always get, or usually get, negative feedback between approvals and submissions. So we need key performance indicators to convince the panels and more people. Sorry if I forgot to write.
Thank you. Okay, next one.
Is it? Magic. Okay. Hello, everybody. I'm Andrea Sacchi. I work at the CFA. Yesterday, I was at the AGN group. So with me, there was Sheena. I beg pardon for the pronunciation of the names, of course. Kartik, Andrea, Matteo, Annalisa, Alfredo, Misag, Anna, Isvaraj, I hope I pronounced it correctly, and Daniele. And the discussion revolved around, okay, we're going to have CRISM, we're going to have another instruments. What will be able Chandra to do, provided we 5 megaseconds, so okay, no time constraints. The main thing which bubbled up eventually was to monitor a very small sample, 1, 2, of already known interesting sources, AGN. So either, let's say, a typical prototype of a class, or maybe 2 prototypes of 2 classes, and then monitor such objects for as long as possible. So let's say the catchy title would be 6 months with an AGN. As many seconds as possible. We know that there are constraints on that, so you need to point the telescope in some other directions. So when you're not pointing with Chandra, we would monitor it with some, for example, Swift to get the continuum. This would allow, let me read because I hopefully phrased it very well yesterday. So this will provide the continuous ionizing continuum measures, and this will allow us to study outflows properties and launching mechanism at different flux states, which is unprecedented in Chandra science history with gratings, such as we know that we need to probably stack observations. So we want to stack the observations which are more or less in the same phases. Such thing is hopefully possible. And this is the right time to do so, because this is the first time we have available cutting-edge time-evolving photoionization models, which is something very exciting for all the community. Apart from this, we were also asked to bring forth some suggestion to the CXC, and the suggestion which came forth is to make available to the community a tool to create narrow zero-order images with HETG to trace extended emission, ideally some sort of quick look tool, so you can select a narrow band and do explore the extended emission in this narrow band. So I think I covered all. If you have questions, you know where the people are. Go and ask them. And thanks for the attention.
Okay, and the last group should be the one on atomic data.
Okay, so let's see. Yeah, we haven't been offered 5 megaseconds of Chandra time, so we felt a bit left out, but also our group was pretty small. No, but like there are a few areas, and this is by no means comprehensive, of course, but a lot of the discussion was about low ionization states near neutral ions and neutral elements, which are very difficult to explore both theoretically and experimentally, because they cannot be produced and probed in EBITs that we heard about, which mostly work for highly charged ions. So there's a lot of uncertainty in like lowly ionized iron, oxygen 123, basically K-shell transitions with ions more than 10 electrons, iron near neutral iron K lines. So these are still problematic transitions. This also basically applies to dust X-ray absorption fine structure, which is also a kind of neutral and needs more experimental confirmation, also metallic iron. Then we noticed there's a great interest in charge exchange. We've also heard a lot of talks about that. None of our group is an expert on experimental charge exchange measurements, but we would think it's important to talk more to people who are experts in these fields and can do these sort of experiments. And then also to look more really actually at branching ratios, which are basically the backbone of all like modeling efforts, but which are also kind of difficult to calculate really carefully, because you have to capture all possible decay channels, and also experimentally capture all the decay channels. And this is also a field that deserves a little bit more attention. I think that's all I can remember. Did I miss out anything? All right, thank you.
And just some summarizing remarks on this discussion.
So as I walked around yesterday and mostly tried to check that people are connected to the Zoom correctly, I found that there were a few themes in several groups, and I just want to answer 2 or 3 of those things that several groups talked about. One is the contamination, the soft contamination that we often talk about is only on ACEs. This is the figure that Rudy Montes made for some soft source. The exposure time you need to collect 100 counts. And you see that the black for the HRC is essentially flat, and for ACEs, it's getting terrible, depending on how soft your source is. If you have a hard object, That's not a problem. If you have a soft object, don't forget that there is an HRC detector, even though we haven't used it a lot in the past. Chandra exposures are getting shorter. Typically, ACES is 30, for ACES, it's 30 kiloseconds or less. For the HRC, it's like 15 kiloseconds, and they're probably going to get shorter over time. Every year, the details will go in the Proposals Observatory Guide, but they're short. They're shorter. So I've looked into the catalog, which combinations of grating and instruments have been used, excluding calibration observations, because calibration sometimes does something that's crazy for other reasons. And so the HETG was designed to be used with ACES, and that's in fact where most of the observations are. ACES, of course, allows us to do order sorting, which is good for the analysis, and it also means there's a very low background, because when you sort orders, you throw out all the photons that can't possibly be at that location, and so your background is very low. When you use the HRC, you can't do that, and so your background is higher, right? Because you don't know what energy a photon has, so they all show up in your spectrum. And when you use the HRCS, your background is even higher than its HRCI, because in that detector, for various reasons, it's just higher. And that's why for the LETG, although it's been designed to be used with the HRCS for the very soft response, a significant number of observations are done with ACES, because then you get the lower background in order sorting. You don't go out to 200 angstroms, but many sources don't have any signal there anyway. However, that's not all. You can use all those in principle. Nothing stops you from using any of those other combinations. HETG ACES with ACES-I as a detector has been done once. For example, HETG HRC with HRCS has been done exactly 0 times so far, and I think it's going to stay that way. But there's some boutique uses. For example, HETG can be used with the HRCI. It's been done 3 times. 2 of those is me. We can't yet make ARFs and ARM-Fs for that in Chow. Hopefully very soon. I'm working on that. But so all these other detector combinations that didn't make any sense in the beginning because ACES was just better are going to be an option for certain boutique uses. This isn't ever going to overtake that one, I predict. But there are certain uses, and in the Chandra's Proposals Observatory Guide actually has a section on that now. And so I just want to encourage you to think beyond like the 3 standard choices that we've always used in the past, because the instrument evolves and some of the things that were best choice in the past may not be the best choice any longer. Thank you.